Sorry, so we're going to do activity today. Go ahead and get into a group. Read the order. Don't get too big, but also I don't mind if it's cooler. We're going to spend the next 10 minutes working on this activity. Making sure that we're staying on task, and then we just go back to spring break.
I would have my house. Thank you.
Well, I can work on it with you if you want to come up here. What time did it end? I guess I'm on the second, okay? I'm gonna talk. No, you guys have to work on it.
I'm trying to.
What are we doing? Are we too serious?
No, we're one.
Well, it's all good. Just work together. I like your talk. What?
Oh my gosh, she's recording.
All right, how's it going over here? Well, I only want
Because it's only affecting one.
All right, boys, how you doing over here?
Where'd you get this picture?
Sorry. All right. Let's make a prediction, okay? Guys, let's see on task. I know we just got back. Let's try to see. I want to come back and check on you, and I hope that you have. Well, I have most of it.
No, it's definitely not. That's what I'm saying.
We'll learn. You just gotta go started. Which one? Why do you think?
Three. Because
Yeah. All right. Well, let's figure it out. Go ahead and explore it. I was going over here, right? Good.
and then 7, 10.
No snacks today, Gavin?
One's not yet.
Guys, don't want to start this off the chart. All right, no. I'll give a minute.
Okay. We can, in the news. And then there's 3.
One. Yep. Good job. Go. One plus 3. Yeah.
So 1, and then there's 2 more.
16.
And then plus 6.
I found out.
Oh, you still have the back. I didn't think that.
No.
Yeah, that's okay. Yeah.
And
So,
then,
you have questions?
and then it's 27.
Why don't you just not take? Are we doing everything?
81.
Good.
81.
That's 43, that's right. Okay, let's look at the second minute. So the second minute, so before, after 1 minute, we have 3 zombies, right? Each of those 3 zombies can infect 3 more zombies.
Oh wait, I thought that was for me. I got it. Affected two more.
Sorry, two more people. My bad. So that means that we're gonna have 9 infected after 2 minutes.
You have to swear. No.
Yes, get the swear.
Oh,
Oh, yeah.
You are affecting what?
Oh wait, we're talking about energy. Yes.
Oh.
No, 81. That's what I said to swear. Wait, no, wait. You said it was
Oh my gosh. I get all the
I erased all of them.
no, the 9.
I asked
I'm sorry, that was. Oh, you just didn't want to.
Okay, so after the first 7:25,
We predicted very much.
And then 2,187. 2,100.
Straight A.
wait, 9.
No, we got,
Okay, so the graphs, real quick, can I have your attention real quick, guys? For the graphs, they could be rough sketches, they do not have to be accurate, okay? All right, go ahead and go back to your, you have about 4 more minutes, so let's try to get at least to where you write part. That was
yes. Yeah.
What?
Yep.
What? You did it. You guys right? All right, let's come in through here. Are these right?
No, because
Yes.
news on me.
I was making sure, Kat. Oh, that's fine.
True.
Oh my God.
If you graph it, that should give you an idea of what the graph should look like.
Wait. Wait, there's probably one.
Are you okay?
We're done. Guess what? Oh,
You have Alan.
but that is the.
Like you can't remember what.
Smell.
Don't eat the.
Yeah, Joe.
Yes.
3 times 2. Let me do something. If that's the
3
issue.
to the x. So 3 is your base. What's the exponent of that? That makes sense? Why do you think this is
Thanks.
yeah. Okay.
Okay, we'll go ahead and go over this worksheet. Yes? Okay, let's go ahead and go over it. Okay, so looking at this activity, we're looking to see different strains of the zombie. So strain A, every minute the original zombie infects 3 new zombies, but the new zombies cannot infect anyone. But for strain B, we have every minute each zombie can infect 2 people. So the new zombies are also able to infect people. So based on this information, how many of you predicted that strain A would create more zombies after 7 minutes? And how many of you predicted that strain B would create more zombies? Who wants to explain why they predicted that? Yeah.
After a couple of minutes, it's not just the zombies.
Right, exactly. So like Sierra said, the main difference between the 2 strains is that strain B, new zombies can affect other people, whereas for strain A, the only one zombie that we start off with can infect people. So let's go ahead and initiate the zombie attack. So now we're going to simulate a virus infection in our classroom. So looking at strain A, after 0 minutes, we should have 1 zombie. How many zombies for strain A should we have after 1 minute? 4 zombies, right? Because that first zombie can infect 3 zombies, so now we have a total of 4 zombies. So then we should get 7, 10, 13, 16, 19, and then lastly, the last number should be 22 after 7 minutes. How many zombies for strain B should we have after 0 minutes? 1. And then how many zombies should we have after 1 minute? 3. So for strain B, each new zombie can infect 2 new people. So after 2 minutes, we should have 9 zombies. How many zombies should we have after 3 minutes? 27. And then 81, 243, 729, and 2,187. That's a lot of zombies, right? How did we do on this part? Thumbs up, we did good. Thumbs down, I have some questions. Okay, good. Let's go ahead and graph this. So now we're going to track the virus. Can I have a volunteer come up to the board and graph strand A for me? Sarah, you want to do it? And then can I have a volunteer for strain B? Yeah, I don't care.
It's a new brand.
It's pretty good. That works. That looks good. Thank you. Okay, so looking at these 2 graphs. Looking at these 2 graphs, what type of function is strain A? Yeah, linear, right? Because we have a linear line. How about for strain B? Exponential. Does everyone see that? How for an exponential curve, we have a curve going on, going up in this direction. And then for a linear graph, it's going to be our straight line. Does that make sense? Okay, so how many of you were right for your prediction in the beginning? I should see everyone's hand up, right? Because everyone said that it should be straight B. Thank you for the enthusiasm, boys. So, looking at the patterns, if we look back at the table you created for each string, do you notice a pattern and how many zombies were affected over time? So this should recall your knowledge from our last chapter with the arithmetic and the geometric series sequences. You should have been able to find a pattern. Looking at string A, what pattern did you guys see? How about the boys in the back?
String A, x plus 3.
What pattern did you see, Bill? Yeah, what is the pattern or what's the common difference? We're adding 3 each time for string A. What about string B? What was its pattern? Is it a little louder? We're multiplying by 3 each time. Did anyone happen to get the chance to write the equation for each of the functions? You want to give it a shot? Katie, yeah? No? I don't know if that's okay. Let's give it a shot. So for string A, you should have gotten 3x plus 1. That's okay, because we know that we're increasing by 3 and we're going over 1. So for this one, our string B, our equation is going to be 3 to the x for an exponential function. I noticed that, and some of you guys had x to the 3rd. That's not the same as this, right? But it's a good idea. So, for our exponential functions, the 3 is going to represent our base of our function, whereas the exponent is going to be our input. So the exponent of the base is the input of our exponential function. Let's go ahead and look at some more examples. So for a parent function, f of x is equal to b to the x, where b has to be greater than 0, and b cannot be equal to 1. And x is all real numbers. You're welcome. So if we were to look at string B, what is the base for string B? Can you say that a little louder? The base is 3, right? Oh, sorry. Okay, on this again. Okay, so let's go ahead and look at graphing example 1. F of x is equal to 2 to the x. Go ahead and plug in those values from the x and y table. So when you plug in -3 to that function that is given in example 1, what value should you get? Okay, so let's recall that when we have negative exponents, it's going to be the reciprocal. So 1 over 2 to the 3rd. Does this kind of bring back memories? Yeah, when we went over radical expressions. So 1 over 2 to the 3rd is simplified to 1 over 8. What about 2 to the negative 2? 1/4, right? What about 2 to the negative first? 1/2. 2 to the 0 is 1. 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. Does anyone have any questions about how we're using the x values from the xy table and plugging them in for x in our function? I don't see it. Can I get some feedback from you guys? So shake your head no if you don't have any questions. Okay. Awesome. Let's go ahead and graph this to see what it looks like. -3. So we have a point at -3 and 1, 8. Don't worry about it being exact on your graphs. We have a point at -2, 1/4, and then a value at -1, 1/2, and then a value at 0, 1, value at 1, 2, and a value at 2, 4. Oh, and then one more value at 3, 8. So we can go ahead and draw what this looks like. Yes. Yes. For the notes? Yeah. Where is our y-intercept located at for this graph? 0, 1. How do you know it's located at 0, 1? Yeah, and how's another way we can find our y-intercept if we don't want to graph it? Right. So to find our y-intercepts, we can set, we're looking for when x is equal to 0, or like Katie said, we can look at our graph to see where our graph crosses the y-axis. Okay, the equation of our asymptote. So as a review, the asymptote is going to be the line that continually approaches a given curve but does not meet it at any finite distance. So that's the word definition. In other words, our curve is going to get smaller and smaller and smaller, getting closer and closer to 0, but it'll never approach it. So our horizontal asymptote for this graph is going to be y is equal to 0. So this dotted line right here. Whenever we're writing the equations for our asymptote, we need to write y is equal to 0. Because it's an equation, we need the equal. What about our domain and range for this graph? Looking at our domain, what would it be? Yes, yeah. So our domain, I think you're looking at y. So we want to be looking at x, yeah. It would be all real numbers. You're fine. So for our domain, that's going to be looking at all the possible values that x can take on. You can write all real, or I will accept negative infinity to positive infinity. Either one is completely fine. It is your preference. What about the range? What is the range for this graph? What is the smallest possible value that y can take on? Yeah. Yeah. So it'd be 0 to infinity. Do you have any questions over domain and range? Okay, go ahead and look at example 3. Don't worry about example 2. We're just going to skip to example 3. Go ahead and work on it with your group. And then we'll come back to it and go over it together. Does that sound good? Example 3, yeah.
Yeah.
Sorry, guys. No, example 3. Once again, guys, skip to example 3.
You don't even have
Yes, Sadie.
Okay. No. I thought you were saying it was too good this stuff. Wait,
How's it going, Commercial Boys?
We gotta make our own.
Oh, yeah, so you need to make points above there.
You did.
You can do 1 or 2. It's 8.
So let me choose one last. Or 0. Anything you're
It's -1.
And this is 0.
You want to grab that?
No,
Please. Oh,
I'm good.
You don't do it right now.
Okay.
No.
Should I do it right?
Yeah, that looks good.
All right.
Thank you.
You're welcome.
No, negative 7.
Kevin's definitely done already. He's done this one.
Okay, for your white percent, make sure you write that.
Thank you.
Right, that makes it real.
Okay.
Okay. Yeah, what's up, guys? Yeah. Alright, how's it going, guys? Okay, so. Alright, well, so give us the line.
That's so crazy.
I don't know what.
I thought it celebrated.
Yeah, you
You're
can
probably
do the line.
No.
Or my mom just thinks
But it's just like this. Yeah, that's right. It's alright. Okay, about 1 more minute and then we're gonna go over this. I have one of you do the domain and then for this.
We can do the domain. Okay, the lowest possible information. Probably over. For the domain.
Yeah, yeah. Oh, sorry. Because I think the
Always so strong.
not all the time. So we're gonna go over that. Like, take one question. Yeah. So, you know Okay, let's go ahead and bring our attention back to the front of the class. And then can I have my volunteers that I talked to about volunteering answers come up and write them on the board? Here's a couple. There's hand sanitizer up here too if you guys want to use it. Yeah. Anyone else see a marker? Yeah. Oh. Okay, here. My bad.
Oh, yeah, I got you.
Oh, sorry. Okay, thank you.
I did not
Wow.
You talking?
In my head.
Oh,
Thank you. Copy.
yeah, yeah. Is that better? No.
I got it.
We're on to, I thought we were, oh. Yeah, sorry, my bad.
We're gonna finish.
Does it?
Wait.
Good job, everybody. Honestly, I would do the same thing if I can.
That's the asymptote thing. It's everyone said it.
Yeah. Yeah.
Okay, so let's go ahead and look at the work that we have here. Thank you to everyone who came up here to volunteer. So looking at example 3, we're given that the function is equal to 1/2 to the exponent of x. So we had Katie came up here and wrote what the x values that she used. So she used -3, -2, -1, 0, 1, 2, and 3. So when she plugged those values in to solve for y, she got 8, 4, 2, 1, 1/2, 1/4, 1/8. Thumbs up, we agree. Thumbs down, we disagree. It doesn't match your work. Awesome. Okay, let's go ahead and graph it. So Bennett graphed our graph for us. So all we had to do was plug in our points again. So we have a point at -3, 8, -2, 4, and then so on. So we see that our graph slowly decreases and gets smaller and smaller, but never approaches this equation of our horizontal asymptote of 0. Do we agree with Bennett's work or do we disagree? Thumbs down. Can I see more? There we go. Awesome. Then for our y-intercept, we have it at 0, 1. So we can see from our graph, that's where our graph intersects the y-axis. How can we also find our y-intercept? What's another way? Yeah. Exactly. We can plug in when x is equal to 0, y is equal to 1. And then the equation of our asymptote, y is equal to 0. Again, I can't stress the importance enough of including that y is equal to on your homework and on your test. Gavin and Joey, do we agree or disagree with their work? More thumbs up or more thumbs down? Okay, thank you guys. Lastly, the domain and range. So if you look at all the possible values that x can take on, we see that it's -infinity to +infinity are all real. Again, we're looking at the range, so all of the possible y values, so 0 to infinity. Do we agree or disagree with Matea? Did you come up here? Yeah, Matea's work. Agree or disagree? Raven, why do we disagree? Okay. Are we feeling good about these examples and graphing these functions?
Yep.
Yes. No, because do you see it? Well, we have to write 0 first. Yep, order matters here when we're writing our points. Okay. So looking at, oops, sorry. Oh well, we get it. Okay, so if we look at example 1 and example 3, let's specifically look at their functions that they gave us. So what was the v value in example 1? Yeah, the v value, 2, right? And what was the v value in example 3? So looking at those values, how do they compare to 1?
Times 2 divided by 2.
So is 2 greater than 1 or less than 1? 2 is greater than 1, and we see, what do we notice about its graph? It goes up. Okay, and then what about example 3? We see, is 1/2 less than or greater than 1? Less than. What do we notice about its graph? It's going down. So if we go ahead and flip our worksheet over, we see that for exponential functions, they are described as exponential growth or exponential decay. So if it's a growth, it's identified as if the b value is greater than 1. If it's a decay, then the b value is less than 1. Does that make sense? Yes? Head shake? No? I have a question. Right? Okay, so it's important that we understand how to identify that b value in our equation. Okay, so for any exponential graph, the y-intercept is always going to be at 0, 1. The horizontal asymptote is always going to be at y is equal to 0. The domain is always going to be all reals. And the range is going to be 0 to infinity. These conditions are true only for the exponential parent graph. Can't stress that enough. No, those are all open parentheses. What?
Why was it the bracket on the other side?
There was a bracket where? These should all be open. Okay, so let's go ahead and look at the standard form for our exponential parent graph. We have f of x is equal to negative a times b to the x minus h plus k. So let's go ahead and break it down. That negative is going to represent a reflection over the x-axis. What do we think this a value is going to represent? Yeah, Katie? Right. Some of this sound familiar to you guys? Yeah? So A is going to be that vertical stretch or compression. What about, so then B is just our base. So again, like in our example in the activity that we did in the beginning, our base was 3. What about our H value here? What do you think that tells us? If we think back to other transformations that we've done to graphs in the past, what has H represented? Anybody? Okay, go for it. Left or right? So the important thing to note about this is that it will change your input values. So that means when you do your XY table, when you're plugging in X, it's always going to, that negative H or positive H will change that input value. Lastly, what do we think K represents? What is the last transformation we haven't done yet? Yeah. Up or down. So this part of the equation will move the horizontal asymptote. Okay, so let's go ahead and look at example 4. What kind of transformations are taking place on this graph? A reflection, right? Because we see this negative right here. What else is happening? Yeah, Cole. It's going right forward because of this -4 up here. So let's look at the base. What is the base value for this function? 2. And Gavin, is that greater than or less than 1? Greater than 1. So do we have a growth or decay? Probably a growth. It is a growth. So when our b value is greater than 1, we have a growth. What is our y-intercept? So that's when x is equal to 0. So if we plug in 0 for this function, what value do we get? So let's write it out. You get -2 to the -4. So then that's going to be -1, 2 to the 4th, which is what? I am hearing it, maybe a little louder. 1/16. -1/16. Okay, so looking at the transformations that we went over in the beginning, we know that the equation of the horizontal asymptote is moving up or down if we have a k value. Do we have a k value in this function? No, so our equation should still stay at y is equal to 0, right? Okay, you guys want to go ahead and graph this one and find what the domain and range is. And while you're doing that, I'm going to be passing out the homework. I'm going to post the answer key for this homework. So that means this homework will be based on completion. How are we doing over here? You feel okay? Okay. No, I would just
I couldn't reach it. You picked it up, right? I'm sorry.
Welcome. No problem. What? Okay, real quickly before you guys go, can you guys give me some key points from today's lesson?
If b is greater than 1, then it's growth.
Yes, I like it. What happens if b is less than 1? Decay. What else? How do we know if we're reflecting over the x-axis?
Then there's a negative.
Awesome. How do we know what our base is? There. If there's a b value and it has an x coding, yeah. Did everyone get the homework?
Yes.
Okay, it is due tomorrow. Please try to complete as much as you can. Answer key is online. Please use it to just check your answers. Please do not copy down the work. Any questions for me before you leave today? No. All right. Thank you guys. Have a great rest of your day.
it eases